Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson. We're going to talk about how to deal with the statistics of reported returns or something similar.
Yeah, it was a question or a comment actually with a question in it that we got this week that was, I haven't got the response back of some questions I asked. And one of the things, Chris, I know you're going to bring up is, well, what are you trying to do? What's the objective? And that I think was actually pretty clear. Is like, I've been asked to calculate how many returns we should expect in the next month. And I'm summarizing.
Mm-hmm.
You know, kind of a forecast of we make a product, it goes out, and we get returns. Well, how many are we going to get based on the trends and the data that we have now? And I won't get into all the details of the thing of the question, but it was basically, I have field data, and they all don't start at the same time. We didn't ship all of our products on January 1st, and then we're looking at time to failure as they come back over the months. But in May, I get products back that are some are from January and some are not from January. They're from other time periods when we shipped it. And the gist of the question was, well, how do I deal with that? And they outlined an approach of basically making the assumption it was exponential, tally up the total amount of time and that they're all out there and total number of failures and estimate lambda and go with that. And I'm like, that may be a problem. And then I said, their basic question is, how do I deal with a data set that doesn't all start at the same time? And I'm like, that's a good question. I don't know that we've talked about that.
Mm-hmm.
So that's why I thought of you, Chris, because you could illuminate the various options a person has to do that.
Yeah, I mean, well, one of the first things we should also mention is that this illustrates why it's very important to gather data and keep track of stuff. If it's not much of it's not that much of a pain to be able to keep better tabs on things, then that's very useful. And it actually, a lot of companies which have in the past sworn black and blue to me that that's just too difficult to be able to work out when this thing came in as a response compared to when it went out. And you go, okay, so you got no idea when this thing was sold or when this thing left the shelf or what have you. No idea. Okay. Do you know who is returning it? Yes, we do. Do you know when they bought it? Yes, we do. Why are we having this conversation?
That's right. You already know everything you need to know.
Yeah. So let's get that one that one off out of the way first. But some listeners will say, well, we do have some clients who they buy tens or hundreds of these things, and when they fail, they return them. I go, okay, all right. The next question I ask is, how do you know that device they returned was in warranty period? How do you know? And the answer to that question, by definition, needs to involve someone assessing or making the call that thing was purchased at a certain period of time or a certain point in time, and now at the point of return, we're still within the nominal warranty period. So that's the second question I ask is, how do you know? I mean, if you are genuinely unaware of when these returns are coming, of the age of these returns, then how do you have any enforceable warranty policy that's going to support any sort of profit margin? And so I'm going to go from the start saying that I'll bet a lot of money that this organization has that information that can be extracted somehow. It might be just that left hand doesn't talk to the right hand, or people guard information fiercely, et cetera, et cetera, et cetera. So first step is really ask yourself, do you have no idea when that particular item that was being returned today was bought? Because I'd question that.
Yeah, I agree. I've run into so many circumstances where the process of collecting the data from the various databases and various different tribes within the organization.
Yeah, that's it. Tribes, yeah.
Yeah, that's the hard part. And it's not always like even dates. It's a big organization. They can't standardize on dates. And
Yeah.
so you pull up the data set, and one of them is in the European structure, and another one's an American structure, and another one's in, sidereal time, depending on the phase of the moon. Like, what is wrong with you people? 10 o'clock is 10 o'clock. Pick a time zone, go. They just, but the way their system evolved, it was, I need a database to deal with customers support, and that's located in Arizona. I need something for the repair center. Well, that's located in England. All right. Well, and they were all generated separately at one point or a time. And it served the immediate purpose of what that database or that process was for. Yeah. Getting customer support to send a Pareto of common failures back to the design was like pulling teeth in some organizations, much less letting them have access to the database. And then they use different language completely, uh,
Yeah.
you know, it's not working. Well, that's not terribly helpful for a design engineer or anybody else. Oh, well, why is it not working? Well, the power supply fell out, or whatever it is. Right. Now we're getting somewhere. But back to just the ships and returns that's a starting point is, well, how many units did you ship every month or every week or whatever time period makes sense for you? And
Right.
do you have a serial number? And it's usually, something like that. Oh, we know we know what week it shipped, or we know what month it shipped. All right. Now you know how many months it's been in service. Well, what about? Well, what evidence do you have that people buy it and put it on the shelf for 3 years before they turn it on? If somebody buys a $500 printer, and it's for a home market, do you think really that's going to be just on the shelf as a backup for the home office for 3 years before they turn it on? Their warranty time is still ticking away, right? And there are some products that when it gets installed, the time starts. And usually the company that sold it is involved in the installation, in, startup qualification and all that other stuff. And those have things on it. And some engines and motors, and we're talking about backup generators in the last episode, they actually have, clocks and hours run, all those other things, useful for maintenance folks, but also useful for is how long's this thing actually been working?
Mm-hmm.
There's all kinds of data out there. I agree with you. And oftentimes that is the difficult part within an organization, to get it sorted and cleaned up and useful. But at the end of the day, we need to come up with some way to get, if I ship 10 products on January 1st and I had 3 failures that came from that batch, well, when did they fail? Is it 3 months or 5 months and 8 months or some other permutation? And then I also know that 7 of those units have not failed. And so the easiest part of this whole process, well, what's today? Okay. Well, today is, as we're recording this, is in February. So that's 2 months then since we shipped that in January. Okay.
Mm-hmm.
So 7 of them have run for 2 months and 3 of them have already failed. And so how many weeks was that? And now we have something we can work with.
Right.
So why do we need that? It's the time to failure data is different than just tallying up how many units are out there versus how many units failed.
And the analytical solution to that becomes a wicked problem. So, I mean, for example, if you sell 10 units on January 1st and you sell 7 units on February 1st, you get 3 returns on February 14th, and you sell another 8 units on March 1st, for example. So those returns you got on February 14th, Valentine's Day, that was random. You don't know if they were from the January 1st or the February 1st sales. And so the analytical solution to that, where you use equations to get the, I suppose, best likely inferred statistical model or explanation, let's call it that, of what's going on, you need to create an analysis tool where you acknowledge that there's a chance that those 3 returned things could either have been released on 1st of January or 1st of Feb. And pretty quickly, if you're having hundreds of components or hundreds of products being released at a sort of a continuum of times throughout the year, and you get a continuum of returns and response, the analytical solution to the statistical problem at hand becomes incredibly complicated incredibly quickly. You almost need to essentially code your own solution and again rely on Markov chain, Monte Carlo simulation, or something similar to get you to where you need to be to work out what's likely going on. And that's in addition to coming up with a likely model that explains why your things are failing.
Oh yeah, we
It's
haven't
just
talked about failure analysis at all yet.
right. So the problem then becomes an incomprehensibly challenging one, which is where you see people go, well, got numbers coming in, got numbers going out. The real answer is too hard to find, so I'm going to get the easiest answer, which is very different to the correct answer.
Yeah.
And you make not weird. It should be weird, but it's not.
Yeah.
You make those ridiculous assumptions about the constant hazard rate. It's not weird because it's so prevalent, which means it's mainstream, not weird. Unfortunately, it's wrong. But the question you need to ask yourself is how, again, it comes back to what decision you're trying to inform for starters.
Yeah.
The reason why that's always important, not just from an analytical perspective, but if you can work out how much money you can likely generate from making a better decision, well, that informs how much money you might invest in having someone translate the database, which is kept in Bristol, UK, and have it interact with the field data reports in Phoenix, Arizona, or whatever the answer is. Because 9 times out of 10, the information is just there. Your bureaucracy makes it challenging to get.
Yeah. Yeah. And I think as a reliability engineer, getting outside of your department or your team or whatever and call the folks at these different deals and say, hey, this is what we're trying to do. This is why it's important. And can I, send me over the files? I don't need access to your database. Just send me the files and just manually go through it, do the conversions, do the calculations. But what we're after is one of the things to keep in mind is that when you ship a product January 1st, that is time zero for that product. If you're not actively tracking when it was installed or turned on or it was, set up on the system or whatever, if you're just shipping a consumer product, let's use inkjet printers because I used to work with them, and you might get some percentage of people saying, well, I'm going to go online and register this product. Now we have a little bit more information, but we have a very consistent information of when it was made, what week it was manufactured. Let's use that as time zero. It's not perfect, but it covers all the products. If it hasn't been manufactured, we don't have a warranty problem with that, or customers don't have it. Yeah, there's a delay before it gets to customers and everything else. It's good enough. Get over it. It's kind of the process I use. Get what's available. And if you need to refine it, if it's worth getting the exact date when it was first turned on, that's a different problem. And is it worth doing? The other part is going off to the customer service or field repairs or wherever we have a record somewhere in the system that somebody said, hey, it ain't working. I need a refund or I need a replacement. And it's a different language. They have a different priority. They're trying to help customers get whole again, get things rectified and solved. They're not in the business of failure analysis. They're not in the business of design changes. They're not in the business of, part of it is, like you mentioned, Chris, is that, oh, okay, your product is within the warranty period. We'll send you a new unit. Or it's not, here's a repair center and here's where you get, sorted out. But they're still aiming at how do we help the customer in one way or the other within the constraints they have. Keeping in mind that these different parts of the organization have very different objectives than figuring out how many are going to come back next year. So it's talk their language, ask them for a favor, get a copy of a file, have them download something for you, ship it to you, or give you access to the database and sort out how to deal with it. Talk nicely to the IT people running those systems, those kinds of things, and just work it out manually. Yeah, it's a pain. It might take you a day or two to get an example set up so you can actually run it through a Weibull analysis and I should say regression analysis. Let's go figure out what distribution this really is, this time to failure pattern we're seeing. And does it tell you a story? Is it a straight line or is it not? Is it informative? Does it, if you were trying to predict last month's returns, is it actually any good at doing that? And so it gives you some credibility to say, I know what it's going to be in the future. At some point, that's going to evolve into just learning how to do regression analysis. And there's lots of software packages out there that you stick the data in with time to failure. I have 15 of them that have 1 month of service on them. I have 28 that have this much service on it. And out of those first 15, one of them failed, and it failed at 3 months, and so on. Sort out your data in that kind of format, keeping in mind that you got to keep the right sensor data, the ones that haven't failed yet. Those still count. You got to include that. And go fit a curve to it, whether it's Weibull, log normal, gamma, which one works to describe your data set.
Mm-hmm.
And yeah, we've only got like 5 minutes left in this. So there's another 2-hour lecture here about what do you do then?
Right.
You know,
but it comes back to that decision. I mean, if the decision is going to have a marginal change on profit margin or decision making moving forward, yeah, okay, maybe some rules of thumbs might be applied. But if you're trying to make some meaningful $1 million decisions, then it's kind of a big deal to invest the time and money to get those different silos of your organization talking.
Mm-hmm. Well, I think that doing it manually the first time and just getting the information as best you can gives you that proof of concept. Yeah, this is useful for us. And then if you want to do it month after month, getting it automated, getting the systems to talk to each other, because it really is important. It's setting up spares, it's staffing for customer support. Is this product line meeting its objectives or is it not? How do we estimate set asides for accruals for warranty? Then it starts to become more integrated into lots of business processes. And all of a sudden, this becomes much more important and easier to make happen because you got those resources behind you. But oftentimes, that first try at it is none of those other organizations care that you need to estimate warranty accruals. It's not their job. You know?
Right.
So they don't. And so just try it. Just get the data as best you can. Keep track of what's not quite good enough and what's is, but get the value. Why is it important to you? Why is it important to the decisions you and the team are making, or it has to be done? And then go from there. But I think to do service to it is once you get those plots and you say, oh, we're going to have 15 failures next month, well, keep track of that. How close are you to actually doing that? Are you using the right models? Is there a fundamental change in what is failing? And that goes back to the failure analysis part, which that's a whole nother bureaucracy of trying to figure out, well, especially if you don't get the products back, if it's cheap enough that you ask the customer, just throw it away.
Mm-hmm.
And it's like, well, what were the symptoms they got? Well, can we afford to have 100 of these units for the next month shipped back to us so we can do failure analysis on it and sort out what is really going on? That's a whole nother process well, once you start collecting this data, well, what do you do with the signals you get?
Right.
So that's probably, if you have a question on that, let us know, because
Mm-hmm.
that's a whole nother podcast series. I think we could do 20 or 30 podcasts on that one. But the first step is get the data. I think that's where you started, Chris, and that I think is perfectly appropriate. Is you can't do the analysis if you don't have at least some idea of what's available to fail and how long they've been there.
Right. And if you don't keep data, or at least don't make it accessible, then you're going to lose by either one, having to pay reliability engineers a lot of money to come up with imperfect statistical analyses where they need to essentially infer what that information that you currently hide away is, or two, make completely inappropriate analysis efforts and come up with numbers which have no real meaning to the decision you're trying to inform, but treat those numbers as if they're gospel anyway. You're going to pay for it later on through additional effort or through, let's just say, damages later on.
Yep. Yeah. No, And I've heard it in some organizations. Oh, we've got all kinds of databases chock full of data, and it's in this format and that format, and we've got all kinds of information. So, all right. So what's the problem? Well, that's the problem is we've got 15 different databases that don't talk to each other, kinds of things. But it's not an uncommon problem as people evolve in their reliability maturity and say, oh, we need to understand this information. And here's the type of data we need. And then you go looking for it. Once it's proved itself as being valuable, then streamlining that process becomes much easier. It is a battle to get the data to start with. The analytical part is just keep in mind they all start at time zero, independent of what month they actually got built. It's not a calendar time we're interested in, is the device time, think of it that way. Mm-hmm. And once we know that, we know so many units are in operation, or we have no evidence they have failed yet. So we call that right censored. And then we have a handful of things that said, well, last Tuesday, Sarah called and said her device failed. So now we have an idea of the duration of the time to failure. And that's all we need to go into a regression analysis and fit a Weibull, for example, on it. Mm-hmm. And then we can use that information to that fitted curve to estimate, well, we've got 1,000 units in the field with all these various levels of duration on it. This curve describes that pattern of time to failure based on the age of those failures and how many were available to fail. And now we can calculate, well, how many should we expect from this mess of different shipments to fail next week? And hopefully they all don't. That would be bad. And but people should know that if it's going to happen. But anyway, there's a summary of it. But I agree with you, Chris. There's lots of ways to solve it. The real solution is get the data as best you can and do a proper analysis on it and make it work. So anyway, if you're listening to this and going, what in the world are you talking about? Or, if you've got a question about how to deal with this kind of data set or where to find it, or I think both Chris, you and I, and I think all the other hosts all have horror stories of collecting data and how it has been mistreated over the years. But let us know. Head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us. Chris and I and the other hosts of the show are available through LinkedIn and our About pages. Plenty of ways for you to get in touch with us. This particular question came through as a comment. And so we watch those too and try to get answers back. And I'm going to update my answer with some of your comments, Chris. So hopefully they give us a little bit more information and hopefully it's helpful for them. So.
Absolutely. It's always good when we can touch on clearly pertinent issues that we find in comments or direct questions. So keep them coming.
Yeah, definitely. All right. Well, thanks, Chris, and keep a lookout for questions for the next time we get together.
Absolutely. Always do.
I tripped you up on the closing line, didn't I?
You did. That's so good.
All right.
It's just not flying today.
Not flying. That's right. All right. Thanks, Chris. We'll talk to you later.
Have a good one, Fred. Always a pleasure.
Always a pleasure. There you go. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.